Howdy, folks. Let's talk about solving one-step equations. Whoa, there's a lot of words. What do they mean? Basically, it means that if we have an equation, we can use these properties of equality that we're going to learn about today and inverse operations to write a simpler version of the equation, one that's also true, also equal. So the first one we're going to talk about, the first property of equality, is the addition property of equality. You can add the same number to each side of an equation. So if A equals B, then you can add C to both sides, and A plus C would equal B plus C. So for example, how would we use that to solve? We got x minus 3 equals 2. We could add 3 to both sides, and we would get an equation that's still true. And that would actually solve for x for us, wouldn't it? Because negative 3 plus 3 is 0, and we would get x equals 5. So this works with subtraction property of equality too. We can subtract the same number from each side. So for example, if we had x plus 3 equals 2, we could subtract 3 from both sides, and we would get plus 3 minus 3, and that's 0, and we would get x equals negative 1. To solve an equation, you must isolate the variable. That means get it by itself with a coefficient of 1. You can isolate the variable using properties of equality and inverse operations. An inverse operation undoes another operation. For example, subtraction is the inverse of addition. Basically, it's like the opposite. It undoes it. When you solve an equation, each inverse operation you perform should produce a simpler, code word simpler. That's not the secret phrase. It's just an important word. It should be a simpler equivalent equation. All right. What is the solution of x plus 13 equals 27? We need to isolate x. We can start out by writing the equation. X plus 13 equals 27. I can undo addition. So now you should always be looking about, all right, I want to get this variable by itself. What's happening around my variable? I have a plus 13. So what's the inverse operation of addition? Well, it's subtraction. So I would subtract 13 from both sides of the equation. 13 minus 13 is 0, so this is x plus 0, which is just x. So then I can simplify a little bit. 13 minus 13 is 0, so I just have x over here, and 27 minus 13 is 14. So if my calculations are correct, x should be 14. I can check my work by plugging it in. X plus 13 is 27, that's what I started with. So if I did my work right, I should be able to plug a 14 in for x. 14 plus 13, does that equal 27? It does. Fantastic. Alright, why don't you try 1a and 1b. Go ahead and pause and then try it out. And push play when you're ready to see me work it out. Alright, so we got y plus 2 equals negative 6. Y is the variable that I would like to isolate. What operation is around my y? It's addition, so I need to do subtraction. So subtract 2 from the left side of the equal sign, and subtract 2 from the right side of the equal sign, using the subtraction property of equality. I have to subtract the same number from both sides of the equation. So what do I get? Y equals negative 8. And then I can check my solution, and I put a negative 8 in. So negative 8 plus 2, does that equal negative 6? And yeah, it does. Yay! Alright, B. In problem 1, why does subtracting 13 from both sides of the original equation result in an equivalent equation? Well, the answer is because of the subtraction property of equality. It says you can subtract the same number from both sides of an equation and get an equivalent equation. Ooh, what is the solution of this equation? Well, you might think, oh, I'm always supposed to do stuff to this side, but no, what you're really supposed to do is locate your variable and tell what you have to do, what operations do I have to undo to get that variable by itself. Right now I have b minus 3. So the opposite of minus 3 is plus 3. So I'm going to add 3 to both sides. Negative 3 plus 3 is 0. So I just got b plus 0, which is b. Negative 7 plus 3 is negative 4. Cool. All right, pause. See if you can figure these two out. All right. Let's see. Here's my variable m. I have a minus 8. What's the opposite of minus 8? It is plus 8. So I need to plus 8 on both sides of the equal sign. And I get m equals negative 14 plus 8. If we remember the rules of subtraction, we would do 14 minus 8 and then give it the negative sign. So negative 6. All right, what do we got going on here? What do I have by my y? I have a minus 3 over 2. So what's the opposite of subtracting 3 over 2? It would be adding 3 over 2. All right, so these cancel out. Another way to say that is they add up to 0. And then how do I do this business? 1/2 plus 3/2. Well, I'm kind of lucky because I have the same denominator already. So I just need to add the numerator. 1 plus 3 is 4. And 4 divided by 2 is 2. Cool. So your secret phrase is Googleplex. And that's actually the word that they got Google from. It's actually like that. A Google is a 1 with a million zeros after it. Did you know that? It's a really big number. And a Googleplex, so a Googleplex is a 1 with a Google zeros after it, even a bigger number. So I would be writing zeros for days, trust me. Anywho, we also have multiplication and division properties of equality, which you might guess mean that you can multiply both sides of an equation by the same number, and you can divide both sides of an equation by the same number. So if you have x over 3, you can multiply both sides by 3. And if you have 5x, you can divide both sides by 5. Cool. Let's see how they work. What's the solution to 4x equals 6.4? Well, I'm looking at my variable and I'm like, all right, we're multiplying it by 4. So the inverse operation of multiplying by 4 is dividing by 4. 4 divided by 4 is 1, so that makes my coefficient of x 1. So I get x equals 1.6. Pause and see if you can do these bad boys. All right. Where's my variable? Boom, here it is. What's being done to my variable? It's being multiplied by 15. So the inverse operation of multiplying by 15 is dividing by 15. So I'm going to divide both sides by 15. 15 over 15 is 1, so I get x. 10 over 15, if you put that in your calculator, you'll probably get 0.66666666. But if you were to just reduce that fraction, 10 is 2 times 5, and 15 is 3 times 5. 5 divided by 5 is 1, so I get x equals 2/3. Alright, how about this guy? My variable is z. It's being multiplied by negative 3.2. So what is the inverse operation of multiplying by negative 3.2? It would be dividing by negative 3.2. Negative 3.2 over negative 3.2 is 1. So I get z equals, let's use a calculator, 14 divided by 3.2 is 4.375. 4.375. But we did a positive divided by a negative, so my answer is going to be negative. Cool. Yeah, and if you were going to grid those, it would be like that. Okay, so what's the solution of x over 4 equals negative 9? Well, here's my variable. What's happening to my variable? It's being divided by 4. So what is the inverse operation of dividing by 4? Well, it's multiplying by 4. So we're going to multiply each side by 4. And then this is like 4 over 1, and 4 over 4 is 1. So we get x by itself, and we get 1x equals negative 36. So see if we can use the multiplication property of equality to solve these two. Alright, so we get 19 equals r over 3. What is happening to my variable? It's being divided by 3. So what's the opposite of dividing by 3? What is the inverse operation of dividing by 3? It is multiplying by 3. So I'm going to multiply both sides by 3. R divided by 3 times 3, those cancel each other out. So we get r equals, well, let's see, 3 times 19 is going to be 57. And B, what's happening to my variable? It's being divided by negative 9. So what's the opposite or inverse operation of dividing by negative 9? It would be multiplying by negative 9. So these would cancel out, and I get x equals 8 times negative 9 is negative 72. Alright. When a coefficient of the variable in an equation is a fraction, you can use the reciprocal of the fraction to solve the equation. So here we got the coefficient of m is 4/5. So what's happening is we're doing m times 4/5. So you might think to yourself, well, it's multiplying by 4/5, so I should divide both sides by 4/5, which is true. But we remember before when we learned about dividing fractions that dividing by 4/5 is the same as multiplying by the reciprocal, 5/4. So what we're going to do is we're going to multiply both sides by 5/4. And what's nice is you get 20 over 20, which is 1. So our coefficient of m becomes 1. And then over here, you're going to do 5 times 28 over 4. But 28 is just 7 times 4. And then 4 divided by 4 is 1. So this is 5 times 7 is 35 over 1. So bada boom. Alright, pause. See if you can do this equation right here. And then B. Alright, so what's the solution of 12 equals 3/4 x? So x is being multiplied by 3/4. So you might say, I want to divide by 3/4. Dividing by 3/4 is the same as multiplying by the reciprocal. So I'm going to multiply by 4 over 3. 4 over 4 is 1, 3 over 3 is 1, so I get x. And then 4 over 3 times 12 over 1. 4 times 12, but I know that 12 is 4 times 3, right? Over 3. And 3 divided by 3 is 1. So those will cancel out. And 4 times 4 is 16. Now I want to check and make sure that that works. Check. So does 12 equal 3/4 times 16 over 1? Well, 16 is 4 times 4 over 4. 4 divided by 4 is 1, so I'm left with 3 times 4, and I get 12 equals 12. So yes, that checks out. So for B, are the equations m equals 18 and 2/3 m equals 12 equivalent? Well, there's one way I could figure this out. I could say 2/3 m, and I could solve this equation for m by multiplying both sides by the reciprocal. So times 3 over 2. These would cancel, and I would get m equals, let's see, 12 is 2 times 6 times 3 over 2. The 2's would cancel, and I get 6 times 3, so m equals 18. So yeah, those are equivalent. All right, using a one-step equation as a model. So toucans, right here, and blue and yellow macaws are both tropical birds. The length of an average toucan is about 2/3 the length of an average blue and yellow macaw. Toucans are about 24 inches long. What's the length of an average blue and yellow macaw? So L is what we're trying to find out here. All right, so the length of a toucan is 2/3 of the length of the blue and yellow macaw. So in math, is means equals, and of means times. So if we let L equal the length of an average blue and yellow macaw, we get 24 that's the length of the toucan. Is gives us the equal sign. 2/3 of gives us times, and then L, the length of the macaw. Then we just got to solve that. We got L times 2/3, so we can multiply by the reciprocal of 2/3, which is 3/2. These are going to cancel. And then, let's see, 24 is 2 times 12. That 2 is going to cancel that 2, and 3 times 12 is 36. So the average blue and yellow macaw is 36 inches long. And you can check by plugging a 36 in for L. 36 is 3 times 12. So the 3's would cancel, and 2 times 12 is 24. So yes, the solution checks out. All right, so let's check out number 6. An online DVD rental company offers gift certificates that you can use to purchase rental plans. You have a gift certificate for $30. The plan you select costs $5 per month. How many months can you purchase with the gift certificate? All right, so $5 a month, $30. So we got $5 times the number of months equals $30. So can we figure out, we can divide both sides by 5, and we get m equals 30 divided by 5 is 6. So we can do 6 months. All right, coolio. There's your lesson. Have fun on practice 2.1. And then formal write-up 2.1. And then I'll talk to you later. Bye.